Hey everyone, welcome to this tutorial on React Query v5, where you will learn the most important parts of React Query that you will need in your day-to-day work as a React developer, including data fetching, mutations, infinite loading, optimistic updates and more, so that you can start working with this amazing library as quickly as possible. But first of all, what actually is React Query? React Query is also called TanStack Query or TanStack React Query because the creator of this library is a guy called Tanner Lindsley. It's a so-called async state manager because it manages data that we fetch from a server. Because whenever we fetch data from a backend, we have one big problem, and that is that it takes time. Sometimes this is just a few milliseconds, but it can be several seconds depending on the connection and the speed of the server itself. Because of this, our front end always only has a snapshot of our server data. It's never 100% up to date because we always have to fetch it, and fetching is expensive. React Query helps us manage this server data by caching it for us, by preventing race conditions, and it brings additional features like automatic revalidation, optimistic updates, infinite loading and more. At the same time, it's very easy to use because it comes with very sensible defaults. We can configure and tweak it if we need, but it's also very easy to get started with it. This library is so popular that as a React developer, you absolutely need to understand how to use it, why you should use it, and why you should never fetch data inside a useEffect. And I will teach you all of this. Make sure to watch this tutorial all the way to the end, because towards the end of the video I will show you some best practices with React Query that you absolutely need to know. Now you might be wondering, now that React is moving more and more towards server-side rendering and we have frameworks like Next.js where we can fetch data directly in server components, is React Query actually still necessary? But the answer is absolutely yes. I use it all the time because there are many situations that you can't do server-side, like optimistic updates, infinite loading, or fetching data inside a component. You have to do these operations client-side. Also, of course, there are a lot of projects in this industry that use React Query, so if you want to be hireable, you should understand how to use it. For this tutorial, I will provide a starting code. I will show you how to download it in a moment. You can use the starting code and modify it together with me step by step to implement these different React Query features, or you can skip the starting code and just apply what you learn here to your own project directly. The starting code uses Next.js, but the concepts you learn here apply to any React framework. One more question I want to clarify. When should you use React Query and when should you use a state manager like Redux or Zustand? As I already explained, React Query manages server state, whereas state managers like Zustand manage app state. Server state is everything that we fetch from a remote server, whereas app state is like a global use state within your app. If you have something like a multi-step form that doesn't immediately make a request to the server, but just needs to manage some state across multiple different pages, then you need a state manager. But if you want to fetch data from an API, like a list of posts, for example, or the number of likes a post has, this is all coming from the server, and this should be managed with React Query because it's much more useful and powerful with this kind of data. It's rare that I need a state manager in the projects I'm working on, but I almost always need React Query. Welcome to Coding in Flow. I'm Florian Walter and I make web dev tutorials that cut the fluff and get straight to the point. If you want to learn at high speed, subscribe to the channel. So, as mentioned before, I will provide the starting code for this tutorial, which you can download if you want to follow along step by step, but you don't have to. You can also apply the stuff you learn here directly to your own project. So I will put a link to this repository into the video description. There will be two branches. One will be called Starting Point and the other one Final Project. If you want to follow along, copy the link of this repository from the video description. Git clone it into the folder where you want to put it. So on Windows we do Shift right click, open the PowerShell here, or the command line, and then we execute git clone and the link to this repository to clone it into this folder. It's called React Query v5 tutorial, and then we open it in VS Code. There's already a bunch of code in here, and I also installed the necessary packages in the package.json. But to actually install them after cloning, we have to run npm install, and then we have to add this flag -- legacy, make sure to spell this correctly, pr -steps. We run this command to install all these packages listed in the package.json. This will create the node modules folder. We can also run this project with npm run dev. Then we can open localhost 3000, and I prepared this front page here. This contains links to the different pages that showcase different features of React Query, but they don't work yet. We will implement them ourselves. But later, when you need a refresher about these different concepts, you can go to the front page and check out these links and descriptions. The project uses a real backend, so we have real server endpoints that we can make requests to. But instead of implementing a database, I just used dummy data that you can find in these data.ts files. So in here we have a bunch of dummy data, and in our server endpoints we fetch this dummy data similar to how we would fetch it from a database. So we have these simulated delays in here. The server endpoints can also throw errors at random intervals, and I try to keep these server endpoints as close as possible to real production server endpoints, as if we would have a real database. Next, let's go back to localhost 3000 and click on this first link here, problems with useEffect, because I want to show you why we use React Query in the first place and why we shouldn't just fetch data in a useEffect. Because before you use a library, you should understand why you use it and not just use it because other people told you so. So on this page we can switch between different categories, and this useEffect here fetches the data for these categories from our backend. Nothing special so far. If you see an error message here while loading data, don't worry, this is expected because our server throws an error with a chance of 10%. And you can find the code for this page in src app problems with useEffect page.tsx. This is pretty simple. We have this state that holds the current category, some buttons that let us switch between these categories, and then we have this fetch with useEffect component where the actual fetching happens inside this useEffect here. And this fetches data from /API/posts, and it sends the category as a search param. This is a server endpoint, this route.ts file under /API/posts. And as I explained before, this mimics a real server endpoint with a delay to simulate that we are making a request to our database, which takes a moment. It throws an error with a chance of 10%, and then it returns this dummy data from the data.ts file. And if you build your own Next.js project, you can use this code here to learn how to set up your own server endpoint. For now, let's comment out this part where we throw the error. Save the changes, and then we go back to fetch with useEffect. One more thing, fetch data is a little wrapper I wrote around the native fetch function that we have available in JavaScript. The reason we have this wrapper is because the normal fetch function doesn't throw an error if we get an error response code like 400 or 500. We have to check this ourselves. If response OK is false, and then throw an error in this case. And this is what happens here inside this fetch data function. React Query doesn't fetch data for you. You still have to do this yourself. You can use fetch, but you can also use something like Axios or Kai. This is up to you. And every React developer usually starts fetching data with a useEffect, which is fine if you are just learning, but there are actually 3 bugs in this useEffect. Take a moment to see if you can find them yourself. We have 3 bugs in here. Pause this video for a moment, check out this code and try to find the bugs in here, and then write a comment under this video and let me know how many bugs you found and what they are. Because practicing like this and trying to figure out things for yourself will help you learn much faster. Okay, so pause the video, and then when you're ready, I'm gonna show you what these bugs are. So first of all, we have a race condition in here. As long as we switch categories slowly, everything works properly. We click productivity, we see the productivity posts. We click design, we see the design posts, and so on. But when we switch categories fast, we will see some weird glitches in the UI, where we see different categories quickly one after another sometimes. Or even worse, it can happen that we see the data for the wrong category, because those are not the posts for design, those are the posts for technology. This happens because these backend requests can take a different amount of time. So we have this random delay in here between 0.5 seconds and 2 seconds. And this is also the case to a real web server, because the request can be faster or slower, and the access to the database can also take different amounts of time. So these backend requests don't always take the exact same amount of time to finish. So now think what happens if I click technology. It starts loading the data for technology, but then I click design immediately afterwards. And the request for design finishes before the technology request finishes, because this one is faster. Then we will first see the posts for design, but then we will switch to the posts for technology, even though we have design selected. This is called a race condition. We will fix this race condition together in our useEffect in a moment. But this is one of the biggest problems you have when you fetch data inside the useEffect, and you have to be aware of it. The second bug is that when we refresh the page, we will see the empty state message for a short moment. So I click F5, and for a short moment, I don't know if you can see it, it says no posts found for this category. Why does this happen? Because we render with a loading state of false when we open this page. Then down here we show this empty message, no posts found. And only a moment later, this useEffect sets the loading state to true, and this empty message is replaced for this loading message. But it's a weird bug and it doesn't look good. For the third bug, we need to trigger an error. So I'm gonna remove the comment here around this error on our backend, and I'm also gonna increase the chance to 90% for a moment. Click a category, and we will see an error message. I set this back to 10%, 0.1. But now when we keep switching categories, we can see that the error message doesn't disappear because we didn't reset it properly. And those are the kinds of problems you have with useEffect. There are solutions to all of them, and I will show you what they are. But you always have to remember them, and they are easy to get wrong. With React Query, you don't have these problems because they are taken care of out of the box. So what we do is, we open fetch with useEffect. We copy this file, Ctrl-Z, Ctrl-V, and then we change the name to a fetch with useEffect fixed. And let's also change the name of the component itself here. So we just replace this name. And here I want to implement the fixes to these different bugs. Then we go into this page here, problems with useEffect /page. And here we comment out this fetch with useEffect fixed, and we also import this from the file we just created. So this is this part over here. It still has the same bugs as the left one, but we are going to fix them now. So the first bug is this race condition, and how to fix it is actually described in the React documentation. We have to implement this weird ignore flag into our useEffect, which is described here. Let me show you how to do this. So at the beginning of our useEffect here, we create a let ignore. Let because we want to change the value of this later. We initialize this with false. Then when our request finishes down here in the try block above set posts, we check if ignore is false, and only then we want to set the posts to the data. Then we have to do the same for the error handler here. Again, if !ignore, we wrap these two lines into this if block, and one more time for the finally block. If !ignore, and we put this line in here. This already looks very ridiculous, but it's necessary. And then important at the end of this useEffect, but still inside this useEffect, right under fetch posts, we return a function like this, where we set ignore to true. And then our race condition is fixed. Let's take a look. Let's switch between categories fast. And this time we don't have these weird glitches on the right side because we cancel the previous request. And we will always see the correct data. So what is happening here? When we return a function from useEffect, this is a so-called cleanup function. Before the next time this useEffect executes, React will execute the function that we return here. So this means when this useEffect runs, we have this ignore flag. But when we trigger this useEffect again, because the category changes, then the ignore flag of the previous request will be set to true, And when the result arrives, so the data or the error, then we check if ignore is still false and only then apply these changes. But if we have another request afterwards, then ignore will be true, which means that we ignore these values. I hope this is understandable. And you need to understand a little bit how closures work in JavaScript. So this useEffect can run multiple times in parallel, right? If we click multiple different categories quickly, then we will have this useEffect running multiple times at the same time. And each of these instances of the useEffect has its own ignore variable. So if we have 3 categories loading, then each of them has their own ignore variable. So they won't interfere with each other. This is why each useEffect can decide for itself if it wants to ignore the returned data or not. So now this race condition is gone. The second problem was the loading state. When we refresh the page, we see the empty state for a short moment. This is actually easy to fix. We can just initialize the use state is loading with true instead of false. So it will be in the loading state as soon as the page opens. Next, we had this problem that our error message gets stuck because we don't reset it properly. And as you can see, this can also show the wrong data because we also don't reset the post state. So we show the previously successfully fetched posts instead. But this category should be empty. It's also a good idea to distinguish between the case that we don't have any posts because we returned an empty array from the backend, or we haven't loaded any posts yet, because those are 2 different cases. So it's a good idea to initialize the state of the post not with an empty array, but with undefined. Then down here we will now get some error messages. So here we add a save call operator. If post.length is 0, we want to show this error state. And down here we put posts and 2 ampersand signs to make sure that post is defined. And only then we can check if the length is greater than 0. Then we show this list of posts. But more important is that we reset the error state and the posts properly up here in our fetch function. So here we call setPosts with the new data. Below we also have to call setError and set this back to undefined. And similarly in the error block below setError we have to call setPosts and set this to undefined to reset the state properly. After saving these changes, our error message shouldn't get stuck anymore. So let's set the error chance to 100% again for a moment to trigger an error. Then set this back to 0.1. And now when I load the next category, the error message on the right side should disappear. And we should never show the outdated data here and not have any race conditions. Perfect. So as you can see, these problems with useEffect can be fixed if you know how, and we could wrap this into a custom hook so that we don't have to repeat this code over and over again. So you don't necessarily need React Query, but most React developers still prefer it. First of all, because it does everything right. All of this just works out of the box and you can't get it wrong. But it also brings a lot of extra features. The main feature of React Query is caching. It puts all the data we fetch into a cache, which makes your app feel much more professional, because when you switch back to a page that you already fetched before, you can show the cached data first, then fetch the new data in the background, and then update the data. And React Query does all of this automatically. But it also brings a lot of other cool features like automatic revalidation. We can implement optimistic updates so that when we do an operation, we see the change in the UI immediately. Or infinite loading lists. All of this is much easier to do with React Query than doing it yourself. But even though this documentation looks a bit scary, most of this stuff works out of the box and we can just configure it when necessary. There are some things you have to implement yourself, like optimistic updates and pagination, but I will show you how to do this in this tutorial and it's not that difficult. Next, let's set up React Query together. And of course, all of this is described in the documentation, but of course you don't like reading documentation. This is why you are on this video. The first step is to install the necessary packages. This one here. And we will also install the DevTools, which are not strictly necessary, but they are really useful. I will show you what they do in a moment. So in our project, we open the command line. We need a new command line. But I already installed these packages in the starting code. So if you cloned the repository, then you don't have to install these packages again. But of course, in your own apps, you have to install these packages yourself. And the command looks like this: npmi, which is short for install, add TanStack React Query, and add TanStack React Query Devtools. Go ahead and install them, but I am using the starting code here. Then we need a React Query Provider. For this, let's go into src, right click on src, create a new file, and rewrite providers / to create a new folder. And in here we put the React Query Provider.tsx file. So we have this folder providers inside src, and then here's this file. This needs to be a client component in Next.js, and we export a default function with the same name, React Query Provider. And since this is a context provider, it will take the children as input. So we define the type like this. We can actually copy the type from the layout.tsx file right here. Or you can just type it out by hand if you are not using Next.js. So the type looks like this. This read-only is not strictly necessary. You can also define the type like this. So we have children of type React Node. This should work in any React framework. To be honest, I'm not sure what the benefit is of read-only, but I'm going to keep it in. It's not related to a React query. It's related to React itself. Anyway, in here in this function body, we need to create a query client, which we put into a state. The reason why we put it into a state is because we only ever want to have one single instance of this client. And if we put it into the function body without the state, it would recreate this client over and over again on every render, which would also reset our cache, which makes the whole cache pointless. So we only want to have one instance. And we can achieve this by putting this into a use state. To this use state, we pass an initializer function, which calls new query client, which is an import from TanStack React Query, and parentheses to call this. So this creates this query client, and we will wrap our whole app into this React Query Provider, which makes this client available throughout the whole app. And then here's the cache of React Query. So this cache is available in all components. If this sounds too complicated, don't worry, just follow along for now. And below we return a opening angle bracket, QueryClientProvider, this one here. We pass the client prop, which is the query client that we created above. We close this, and in here we put the children. The children are all the child pages that we put into this provider. In other words, the children are our whole app later, because we will wrap our whole app into this React Query Provider. More on that in a moment. And below the children, still inside this provider, we put the React Query Devtools. This is why we installed this package earlier. We import this, and we set initial is open to false. The next step is to wrap our whole app into this React Query Provider, so that we have this query client available everywhere. How you do this depends on the React framework you use. In many React frameworks you have an app.tsx file which wraps your whole app, and this is where you put this provider. In Next.js we have the layout.tsx file in the app folder which wraps all our pages, and this is where we have to put the React Query Provider in Next.js. So we import the provider that we just created and wrap the children and also the toaster, so everything inside the body, in this provider. And the children are then the pages that we render in here as the children prop. This is how context providers work in React. And that's it for the setup. Save everything, and then we can use React Query in all client components in our app. Then next, let's go to localhost 3000 to our front page again and click on this basic React Query link here. I've already set up this page. We can find this page under basic React Query page.tsx. But I haven't implemented React Query yet. This is still commented out. We have to create a component with this name here. In the same folder, basic React Query, we create a new file called fetchWithReactQuery.tsx. This is the component where we will use React Query. From this file, we export a default function with the same name, fetch with React Query, and it has to take the same props as our useEffect components, which are the category that we selected. And we also have to set it the type of this prop because we use TypeScript. Just copy this, and then we use our first React Query function. We create a const which we destructure and we assign it to useQuery, which is the most basic way to do a query with React Query. So we call this, we have to set the type of the data that we get back, and this type is what we get back from our backend. We can take a look into this fetch with useEffect fix component that we already have. The data is a post array, and post is this type I set up in this data file. This is the same data we expect in this query. So we paste this here and import it from the data file, close this. This way we will get type safety because now React Query knows what kind of data we fetch from the backend. Then afterwards we write parentheses and curly braces because we have to configure this. Every query in React Query needs a query key, which is the key that identifies this query in the cache later. The query key is always an array, and you can put one or multiple values in here. For example, we can put a string in here that says posts. And now when we fetch these posts, they will be stored in the cache under this key. And if we need to update them or make changes to the cache, we can always find this entry under the string. And if we fetch this data with the same key in a different component, it will fetch the data from the same cache. So the cache will be shared between different places. Because again, the cache is available from this React Query provider that wraps our whole app. Now one important thing, we have an argument here. We have different categories, right? And right now when we switch categories, it would overwrite the previous entry in this cache. So let's say we fetch technologies, it gets put into the cache under this key. But then we fetch the design posts, then it will be put into the cache under the same key, which means that it would overwrite the technology posts. This is why you always have to put these arguments into the query key as well. Now each of these different categories will have its own entry in the cache. We will take a look at the cache in a moment, but the cache will always have this combination: posts, technology, posts, design, posts, productivity, and so on. So all arguments that you use to fetch your data, like the category, have to be part of the query key. If it's still confusing, don't worry, just follow along, you will understand this in a moment. And then the second argument we need is a query function. This is what actually fetches the data. And to this we pass an arrow function, and we basically want to do the same as over here. We want to fetch data from this endpoint, right? And pass the category to it. So let's paste this over here, import fetch data. Now actually, since we define the type of this data down here, we can remove the type argument from useQuery because React Query is smart enough to infer the type from the query function. We can leave it in both places, but we can also remove this up here. And now in this destructured return block here, we will find a lot of different values. The ones we care about is the data. When we hover over this, we can see that this is of type posts or undefined because we defined the type here. And it will be undefined as long as we don't have any data yet. Let's rename this variable to posts, like this. Then we also want this isLoadingState, isError, and all of these states are managed by React Query for us. So we don't need to manage a bunch of different use states like before. And if an error happens, we also find this variable in here. And this is the most basic setup of React Query, and this will just work. The only thing left is to return a UI here. For this, let's put fetch with useEffect fixed on the right side, because I'm gonna copy most of this stuff. So we copy this part up here with the headline, which will be the same over here. This also needs a div closing tag at the bottom, like this. And then in here we handle our different states. It will look slightly different than over here. So here we put an expression which checks if isLoading is true to ampersand signs. And if isLoading is true, we want to render the same loading div as in this fetch with useEffect fixed component. So let's put it in here. Below we also check if isError is true to ampersands. In this case, we want to render the error message, which is the same component as over here. Copy this. And instead of just error, we want to render error.message. Then below, we also need an empty viewer, which is this part here. No posts found for this category. Let's paste it over here. But we changed the conditions slightly. So this should be shown if post.length is equal to 0, if isError is false, and we need one more, if isLoading is false. Then we want to show this empty state. And finally, at the bottom, we want to render our posts, for which we can copy this block here. Post and post.length greater than 0, and then we render this UL component. And by the way, you can hover over these different variables that we get returned from useQuery to learn what they do. For example, isLoading is true only for the first fetch. So when we refetch our data, this will not be set to true again. Instead, we will see the cached data later. But you will see how this looks in just a moment. So now the next step is to uncomment fetch with React Query in the basic React Query page and import this here. And then we can see our new fetch component in action. So we go to localhost 3000, basic React Query. Let's refresh the page just to make sure. We see the loading state. And this now just works when we switch categories. We load the next category. We won't have race conditions in here. And as you can already see, we don't see loading again when we switch to a category that we already opened. Why? Because we show the cached data. Again, if an error message shows up, this is expected because our backend throws a random error. And this little icon down here are the React Query Devtools. Here we can look into the cache, and this is really cool. So we have 3 entries, and this is the query key that we defined. It's always posts as a string, and then the categories. We have 3 different entries. And when we click empty category, we will have a 4th one. We can even look at the data in here when we click on it. This one is empty because it's an empty category, and in here are these 3 posts. And this yellow color here means that this data is stale. So the next time we switch to this category, it will be refetched, and refetched has the color blue, this one here. So you will notice that when I click on technology, for example, this will immediately change to the color blue, which means that it refetches the data in the background, and then it will change to stale again. So let's click technology. It's blue and it becomes stale again. So what this does is, as soon as we click a category, it shows the cached data immediately. This is what we see right away. And then in the background, it goes ahead and fetches the latest data. And if there is new data, it updates the screen. We can't see the update right now because we always show the same data. But what we can do is we can go to our data.ts file in the posts folder here, add a new post, to design just for a moment to simulate that we are getting new data. I just set the title to blah blah and the body to blub blub because I'm not the most creative person. But now when I save this and when I switch back to design, what will happen is first we see the cached data, which are only these 2 entries here. Then it will refetch the data, and a moment later it will then show this additional post. Let's try. We see 2 posts, it fetches, and there's the other post. So this looks much more professional than fetching in useEffect and showing a loading indicator every time you open the page, right? Let's remove this again, save this, and again we can switch back and forth to update this. Or what we can also do is we can open a new tab, then go back, which automatically triggers a refetch for the latest data. Isn't this cool? This just works out of the box with React Query. We can disable this if we want, but it's really useful. And as I mentioned before, this cache is shared throughout the whole app. So if we have a different page where we want to show our technology posts, then it will use the data from the same cache if we use the same cache key. This will make our app feel much faster. Let's see what happens when we get an error. For this, again, for a moment, I want to throw an error with a 100% chance in our backend here. And I also want to open the console to see the log messages. So let's switch categories. We see our request to technology, it fails. And then we see the same request 2 more times because React Query automatically retries this request a couple of times before it finally shows the error message. Looks like it was 4 requests in total, so it retried 3 times. It still shows the cached data. If we want it, we can configure this ourselves. We can also disable the retries or change the number or under which conditions it should retry. But out of the box, it retries 4 times and it also automatically resets the error state. So if we try to load technology again and it succeeds, the error message disappears. When we refresh the page, it clears the cache. So this is not stored across different page loads. This is just state throughout your React app. But when you click F5, it will clear all these caches. If you want to store data across multiple requests, you have to put them into a database. This is not directly related to React Query. React Query is just about fetching data from our backend. As I mentioned before, we have a lot of configuration options here in this useQuery hook, which we can add below our query function. When we press autocomplete, we get a lot of different suggestions here with which you can configure and customize React Query. For most normal cases, the defaults are already pretty good, but we can, for example, set retry. We can set this to a number, like we want to retry 10 times before it stops. We can also set this to a function and return a boolean so that we can dynamically decide when it should retry and when not, or we could just set this to false to never retry. We can also change, for example, refetch on window focus. This is what we saw earlier when we switched tabs. We can set this to false to never refetch when we focus the window again. You can learn about these other configuration options in the React Query documentation, but again, the defaults are already pretty good. Next, we will learn how we can do a search with React Query, because this is a very common use case. So let's click on the debounced search with React Query link on our front page and go to this page. We can find this page under search query page.tsx. I already prepared this. And in here we find this post search component, which I also already prepared, but most of the code here is commented out. So let's remove this comment here in the return block like this. We get some errors. We have to do some imports here. Let's import input from the components folder, button from the components folder, and this should be it. These values will come from React Query, of course. You will also notice this use debounce hook up here. In case you don't know what debouncing means, it just makes sure that when we type something into our search field later, we don't execute the search immediately, because then we would trigger a request to our backend with every single character change. Instead, this use debounce hook will fire after we stopped typing for a delay of at least 500 milliseconds. This is what this hook does. I won't explain what happens in here, but this is what this is for. So when we type something in and wait for half a second, this will then trigger the search. It will not trigger it immediately. You basically always need this when you run a search that fetches data, because otherwise it would be very wasteful. Okay. And here above the return block, we want to call useQuery again. Again, parentheses, curly braces. This needs the query key. Again, we set this to a string posts. Then we add a second one that says search. We do this so that this cache doesn't clash with our categories that we fetch, because they have a similar cache key, right? Here we have posts and then the category. So for example, posts technology. And here we will have posts and the search term. But if we search for technology, then this would override this cache key here, right? Because this would have the same key, posts and technology. So to avoid this and give this its own key, we are more specific. We say those are also posts, but specifically for the search. And remember, as I explained earlier, when we have a variable that we use in our query, we always have to put this into the cache key. In this case, it's the search term. So every search term will have its own entry in this cache. And we will take a look at this in a moment in our DevTools. Then again, we need a query function, which looks very similar to what we did before. We pass an arrow function, which calls fetch data, which again is of type post array, which we declare here. And we make this request to /API /posts /search, which is this endpoint I set up here. This is similar to the other endpoint, just that this one takes in a search parameter under this key, and then it searches through all our categories, and then return the posts it found. So this expects a search param in the URL, similarly to how we send the category here, like this. We want to send the search query here as a search param, but instead of category, this will be the search term. So the name of this param is search, and the name of the variable is search term. This key here has to match the name of the key that we expect on the backend, this one here. They are both called search. But actually, this should be the debounced search term, both in the query key and in the query function. Because we only want to start searching when the debounced value changes, and React Query automatically refetches data when the query key changes. So we only want to trigger this after our debounced duration, not as soon as we start typing. So it's important that we use the debounced search term here, and that we also send this one to our backend. One more thing, by default this will start fetching as soon as we open the page, but when this happens our search term will be empty, right? And then our backend will actually return an empty array, because here we check if the search term is empty and then we return an empty array. This is a bit wasteful. So we want to tell React Query, wait until we typed something into our search. We can do this with the enabled prop. We can set enabled to a 2 exclamation marks debounced search terms. So only if debounced search terms is truthy, which means that it's not empty, this query will start. This is what this enabled prop is for. And then again we can destructure the data, which again I want to call posts, and the values we need is loading, is error, and the error itself. And then we shouldn't get any errors down here anymore. Let's save this and try this out. So now we see this UI and we can start searching. And remember, the search is debounced, so only after I stop typing, we will trigger an actual search. So let's try this out. Let's type React. I wait for half a second and it starts searching. And then it will show the posts that have React in them. Now we should have one entry in our cache, which says posts, search, and React. We also have this empty one, but this one is disabled because of our enabled prop, so we can ignore this. So now we have a cache entry for this search query. If I remove a character, we still see the same results, but we have a separate cache entry because now the key is different. And this is exactly what we want, because the cool thing is now, if I type in React again, we don't see the loading state. Instead, we see the cached data immediately. So again, this feels much faster. And when we type in some gibberish, it will say no post found, but again, it will cache this entry here separately. So this is how you run a search with React Query. Pretty simple, right? And remember that if you have more variables that you want to send to the backend, for example, let's say we still had our category buttons here, then you also need to put this value, this variable, into the query key. So as a rule of thumb, every piece of data, every variable that you send to your backend has to be part of the query key to avoid overriding existing cache entries. But we not only do this to avoid overriding the cache, we only do this to trigger a refetch, because remember, only when the query key changes, the query runs again. So all the variables that can change need to be part of the query key, remember this. Alright, these basics will already get you a long way with React Query, and now we will learn the more advanced features. Make sure to watch this video all the way to the end, because I will also mention some best practices that you need to know when you work with React Query. Next, we will learn about infinite queries with React Query. This is really cool because often you load a list of data like comments, and then you have a load more button at the bottom, and when you click it you load the next page, or you want it to load automatically when you reach the bottom of the page, like on a social media website like Facebook. And you can do this with React Query. I will show you how, and I will also show you how you can create new data and put it into this list efficiently without long loading delays. But for now, let's focus on this infinite loading feature. So again, I prepared some dummy data that is in the starting code. Under API comments data, we have some fake comments here with a timestamp, text, and some user data. Then we have this comments backend route, which again is the server endpoint. And here again we pretend that we fetch comments from our database, but it's just a normal array, it's not a database, but I kept the API of our functions, very similar to how it works when you use something like Postgres or an ORM like Prisma. So this is very similar to my Prisma code I use in my project tutorials. If you want to see a real production case, you can watch my project tutorials, like the social media app tutorial on my channel, where we implement infinite loading with a real database. But again, here we have dummy data. So we have this get endpoint to which we have to pass a cursor. A cursor is how we figure out what the next item is that we want to continue loading at. So this is the ID of the next post that we want to fetch so that our backend knows where we have to start the next page at. So our page size is 5 here. So the first page will return these 5 items and the cursor will be the number 6. And then we know that the next request should return these 5 items and so on. And this is all handled on our backend. Again, we have a random error and a delay to simulate database access. And this function here gets the data, the comments from the data array. And this code looks very similar to what I do in production. So when we take a look into my social media app repository, which is public on GitHub, and this is the code for my YouTube video, here we will find, for example, a for you route on the backend for our for you posts. Here again we have a page size, we send the cursor to the backend, and then we fetch the posts from Prisma. To it we pass the cursor. We do the same in our React Query project, just with fake data. And to get the next cursor, I return the page size plus 1. So we return one additional item. And this one additional item then becomes the next cursor. And if there is no additional item, then we know that there is no next cursor, which means that we reached the end of our pagination. And we do the same here in this project. We return one more item down here, take plus 1. We make this the next cursor, but this can also be null, which means that we reached the last page. And then we also have this post endpoint to post a new comment, but this is for later. So really the best way to learn this is to build a real project, like in my social media app tutorial, and follow along there. You just have to implement this 1 or 2 times and then you will understand how this works. Okay, the rest happens on our InfiniteQuery page file, this one here. Again, most of this is already set up. This is all the text you can see here. And in here is this infinite comments component where again we have some commented out code. We remove the comment here. And for now we ignore this comment form. This is this input form where we can create a new comment later. But for now we want to focus on infinite loading. So again, above the return block, still inside this component, we destructure a const. But this time we don't call useQuery, we call useInfiniteQuery, which is a special hook for infinite loading. Again, this takes a query key. We just set this to comments as a string because here we don't need to pass any arguments. And then a query function. The query function is slightly different because now we get an argument here, which we destructure with curly braces. This is called page param. The page param will contain the next cursor. We send this to our backend route so that we know what the next cursor is and where we have to start loading the next page, right? Of course, as usual, this is also described in the React Query documentation, if you want to read up on this. But the rest is actually pretty simple and easy to understand. We call our fetchData function again. We define the return type, which is comments response. I set up this type here in our backend route. This just defines the type of the data we get back. We get this page of comments, the next cursor, and the total number of comments so that we can show this in the UI. This is the data we get back here. Again, this gives React Query type safety, so it knows what type the data is. Parentheses, backtick, string, and here we have to pass the endpoint where we want to fetch from. It's under /API/comments, and then we have to send the cursor to our backend. So we make a question mark, %sign curly braces to put a variable in here, because our backend expects this cursor argument, right? Under this name here, cursor as a string. So we want to put it in here. The cursor will be this page param. But this can also be undefined for the first page, because then we don't have a cursor yet. So what we do is, in this expression, we check if page param is defined with the ternary operator, question mark. Then we want to set this to cursor equals, again a variable in here, and this is the page param. But if the page param is undefined, we append an empty string. So again, we call this endpoint here and we put cursor equals in there only if the cursor is defined. Otherwise, we only have the base URL. Then we need two more arguments to use InfiniteQuery. One is the initial page param. This is the very first cursor, right? The first cursor is undefined because for the first page we don't have a cursor yet, right? But React Query needs to know the type of the cursor and it infers this from this initial page param. But undefined is not the type we expect. It's number or undefined, right? Because the IDs of our data are numbers. So what we do is here we assert the type with s number vertical bar undefined. This helps React Query understand the type of the page param. And now we should also get type inference up here from this page param. So React Query should understand that this is a number or undefined, but there is so much text in here that I actually don't understand this. So let's just ignore this and add the last argument here, which is get next page param. Because of course we have to tell React Query where it can find this cursor. So let's think we return the cursor as part of our response in this next cursor field. To this prop we pass an error function which receives the last page. This is the last page of data that we fetched. And in here is the cursor, last page dot, and we get autocomplete because we set the type of our response, next cursor. So now we have all the puzzle pieces in place. Now React Query knows where it finds the cursor. It knows what it should do with the cursor, put it into the URL if it is defined. It knows what the first cursor is, that's undefined. And it uses this information to fetch all the comments. And again, we can destructure the data here. Data is loading, is error, the error itself, but now we have a few additional values that we need. Fetch next page, which is a function that triggers the next page load. Has next page, I think this is self-explaining. And is fetching next page should be self-explaining as well. Those two values are booleans, true or false. Okay, so the useInfiniteQuery hook is a bit more involved than the default useQuery hook, but in return we get really nice pagination. And this data is actually now not an array, it's infinite data, which is basically an array that contains multiple arrays. You can imagine it like this. We have an array with our different pages, but in here we have an array with the page 1 items, then another array with the page 2 items and so on. And we want to get our comments out of this nested array so that we can render them in the UI. So below we create a const comments. We take the data dot pages and then we call flatMap. FlatMap turns a two-dimensional array into a normal array. Here we take each page and we map this to page.comments. So this takes our two-dimensional array of data. It takes each page. It extracts the comments out of this page, and then we have one array of comments or undefined if we haven't fetched any data yet. So this is what I always do after calling useInfiniteQuery to turn the data into an array that we can display in the UI. And that's already it. I prepared the UI earlier, but this looks very similar to our other pages. We show a loading state, error and empty state. And at the bottom we render our comments. It's really pretty much the same as we have in our normal useQuery cards. But of course one more addition, we have this load more button at the bottom that checks if has next page is true. Only then it shows the load more button, which triggers the fetch next page function, which then makes React Query fetch the next page. And as long as it's fetching the next page, this button is disabled. Very straightforward, just one more change. Somewhere up here we have our H2 headline. Afterwards I want to show the number of comments we have because we return this value from our backend. Let's put this into parentheses. In here we put an expression, close this, close the parentheses, and in here we check data pages at the index 0 because in the page is the number of total comments, and this will be the same for every page. It's part of the page data that we return, but this can be undefined. If it's undefined, so before our first fetch has returned data, we just render the string with a minus in there. Okay, let's save this and try this out. So now we immediately see the first page of comments. The page size is 5. We defined this here on the back end in this page size variable. And as I wrote in this comment, you could also send this as a query parameter. You can also send this page size from the front end to the back end. Again, this will randomly throw an error with a chance of 10%. And now when we click the load more button, we should load the next comments. So we have the first 5. The last one is Noah White. The next one should be Emilia Baker. Load more comments. Emilia Baker. Liam Taylor is the 10th person. The next one should be Scarlett Phillips. And then we can keep loading and loading. Sometimes this will throw an error. Sometimes it will take a bit longer, but this is all just simulated. And once we reach the last page, we don't see the load more button anymore, because we didn't return a next cursor. The next cursor is null, so React Query knows that there is no next page. This is how you do infinite loading with React Query. Wasn't that difficult, was it? But it allows you to create really cool features in your app. If you want to automatically load the next page when the user scrolls to the bottom, you need some kind of boundary detector. There are libraries for this. And again, you can look into my social media app tutorial where we implement exactly this. There, when we scroll to the bottom of our feed, it automatically loads the next page. But the simplest way is to just have a button that loads the next page. So again, check out my social media app tutorial to learn more. Before we go to the next topic, which are mutations, I want to organize our code better, because this component here is getting quite verbose, and it's good practice to wrap your useQuery functions into a custom hook to hide this logic here. So let's do this. We cut out useInfiniteQuery all the way to the end, and we create a new file in the same folder, InfiniteQuery. Let's call it use-comments-hooks. You can name this anything you want. This is a TypeScript file, not TSX, but just TS. And from here, we export a function, not a default export, because we will export multiple functions from here later. And we call this useCommentsQuery. Custom hooks in React always have to start with the word use, otherwise we can't use other hooks in here. And from here, we simply want to return useInfiniteQuery that we just cut out. We have to fix these imports. We import the hook, fetch data, and comments response. And now this should compile again. And then we can simply use this hook over here, which makes our code easier to read. Simple. This, of course, also has the benefits that we can now use this hook in different places. And all of them will be connected to the exact same cache. Really cool. Next, we want to learn how to use mutations. You need a mutation whenever you want to post data to your backend. For example, to create a new comment or update an existing comment or delete one. Those are all mutations. So let's learn how we can do this with React Query. Let's put this mutation into the same file as our useCommentsQuery, into the useCommentsHooks file. Here we export another function called useCreateCommentMutation. You can also just call it useCreateComment, but I like to be explicit. And for mutations, React Query has a specific hook, which is called useMutation. We import this and we return it from our custom hook. Again, we call this, but this one doesn't take a query key because this doesn't fetch data, it just posts data. But we have to pass a mutation function, parentheses. To this mutation function, we can pass any variables that we want, but it has to be wrapped into a single object. What do we need to pass to our backend? Well, the text of the comment we type in, right? So we could either declare it like this, text:_string, this would work. We can also wrap this into an object, which is especially important if you have multiple different values. So you can also wrap this into curly braces and give this a name. New comment colon, which has this text inside it, and here we could add additional arguments like title string, for example. But in this case, we only care about this text. It's just important to remember that this argument has to be a single object or a primitive type. You can't pass multiple values because React Query doesn't accept this second value here. It's not part of the variables anymore. Okay, that's the mutation. And then we make a right arrow. And when we call this mutation function, we want to call postData, which is another function I set up in the fetch utils file. Again, this calls the fetch function. We give it a URL and data that we want to post. We can make this of any type. It sets the correct headers and method, and then we can use this to send data to our backend. This is standard stuff. So we call this here. We want to post this data to /API/comments. Remember, here I also have this post endpoint already set up, and this pretends that we add a new comment to our database. But again, we don't have a database, so instead we just put it into this comments array. This also works. This way we pretend that we created a new comment. Here I also hard-coded our user data. Our name is current user. In a real app, this would be coming from your authentication system. Again, you can see a real example of this in my social media app tutorial. Normally, you would fetch the current user data from your authentication provider and use this to create the comment. But the rest is pretty standard stuff. Again, we have a random error and some artificial delay in here. So to this endpoint, we want to post our new comment, and the second argument of post data is the new comment itself. Then we make a comma, and we can also pass this onSuccessHandler, which is another function like this. We pass an error function. As the name implies, here we can do something after our mutation was successful, so after we get the response back from the server. And one thing we have to do is we have to revalidate our query. We have to refetch these comments, otherwise we won't see our new comment in here, because this doesn't happen automatically. To trigger a refetch, we need a query client, which we can get like this. Const queryClient equals useQueryClient. We call this in here. And then we call queryClient.invalidateQueries. And to it, we have to pass the query key that we want to invalidate. We want to invalidate our comments query, so we have to use the exact same key, comments as a string. This will tell React Query that this data is stale, and it will immediately go ahead and fetch the newest data. So invalidate queries basically means refetch this data. There is no refetch function on here, where there is refetch queries, but this is something different. To trigger a refetch of our data, we call invalidate queries. I can already tell you that this approach has some downsides, and we will learn a better way to handle this in a few minutes. But for now, this is the easiest way to refresh our list of comments. Okay, next we go into the comment form component, which I already set up in the starting code. This is this input field here. The code that's already in here is pretty standard React stuff. We store the input in the state, and then we have a submit function, which does something with the input. And here we want to trigger our mutation. To get a handle to this mutation, we have to call the hook. So we create a const mutation equals useCreateCommentMutation. This is the hook we just created here in this useHooks file. Then here in handle submit, after we checked this trim and before we set the comment text back to an empty string, we call mutation.mutate, parentheses. To it we have to pass the variables, which are the text string that we defined here as the argument to the mutation function. So we have to pass this value here when we call the mutation, which is an object that expects the text, and the text is the comment text that we typed into the input field. We send this to our mutation. And then as the second argument, we can also pass the same onSuccess callback that we have in here. So we have it in useMutation, but also here when we call mutate, we have it 2 times. So when should you use which? Everything that's closely related to the mutation itself, like invalidating the field, I would put directly into the useMutation hook. But everything that is related to the UI, so to the component itself, I would put in here into the mutate call. So for example, after this was successful, we want to do 2 things. We want to set the comment text back to an empty string, right? And I also want to show a toast message, which we do with toast, which is an import from Sonna.success. And this will say, Comment posted successfully. We could also put this toast message in here into the success handler. This would still work, but it's a better practice to put it into the component because this is UI code and the component is the UI layer, so to speak. But again, this is up to personal preference. We can also pass an onError handler here, which I think is self-explaining. And in here we want to call toast.error and it will say failed to post comment. Please try again. Now you might be wondering, what's the point of using this mutation here? Why don't we just call our post data function here directly in the handle submit function? And this is a good question, because this would have the same effect. We could still wrap it into try catch to show our error toast, and we could do something after the request has finished. And you shouldn't use a library or an API without understanding why you use it. And strictly speaking, you don't have to use useMutation. You can also do it the way I just explained, but it has some benefits. For example, this mutation object here has some useful states like is error or is pending or is success that we don't have to manage ourselves. Then we have these callbacks, which are useful so that we don't have to wrap our code into a try catch, for example. And there's also an error state on the mutation. So we get a bunch of benefits that are handled by this mutation. But again, you could also just execute this the normal way by wrapping it into a try catch block. Oh, and one more cool thing, we can also configure automatic retry when we use useMutation. This is not activated by default, but it's an option here if you want this. And again, this is one of the benefits you get from using React Query instead of doing it yourself. But I would say the most useful features of useMutation are the states that we get out of the box. We can use them, for example, to disable our input while a mutation is in progress. So here we put mutation is pending, which is true while the mutation is executing. And similarly, we can change the button of the text. Here we check if mutation is pending is true. In this case, this will say posting ... and otherwise it will say post. Let's also disable our submit button when the mutation is pending. So after comment text trim, we add 2 vertical bars and again check if mutation is pending. Okay, let's save this. Let's refresh the page just to make sure and then try this out. YOLO. So this is comment number 26. We post this. It was successful, and a moment later we see the new comment in the list, and it seems to work pretty nicely. We post a new comment, and a moment later we see the new comment on the screen. But there are some problems with this approach. The main problem is that when we call invalidateQueries on a paginated query, it will actually go ahead and refetch every single page one after another, starting at the first page. And we can see this by loading more pages. So page number 2, 3, let's load all pages. Because then it will look quite different. Come on, go ahead. Load more comments. Okay. So now again, if I post another comment and this succeeds and it invalidates the queries, it will refetch page 1, page 2, page 3, page 4 and so on, one after another. And only then we will see the latest comment on the screen. And it will take much longer than before. So we have to wait for several seconds and then we see our comment. This is not a great user experience. Now, one simple solution that is still pretty bad would be to return invalidate queries from onSuccess. So we return the promise that this returns. This will cause the mutation to stay pending until this has finished. So this means we make a new comment and this stays in the loading state until all pages have been refreshed. And then we immediately see the new post. But we still have the problem that it has to refetch all pages one after another. And the more pages we have loaded, the longer this will take. This is still pretty bad. The better solution, in my opinion, is to not call invalidate queries when we have multiple pages, because this takes too long, and instead mutate the cache ourselves, which means that we go into this list in our cache and we put our new comment in there ourselves. Then we don't have to wait for a refetch. So let me show you how to do this. So usually when you post something to your backend, like when we post a new comment to our route handler, you return the thing you just created. Like here we return our new comment from this post endpoint, and we receive this when we call this post endpoint. So why can't we take this comment we just created and use that in our list instead of refetching the whole list? And guess what? We can do that. It's just a bit more complicated than simply calling invalidateQueries. But here in the onSuccess handler, we get an argument, which is whatever we return from the mutation function. But for this, we also have to define the return type here. Otherwise, React Query can't infer this. So on the post data, we can add a type argument right here before the parenthesis. And in here, we define the type that we get back. We get a comment back in an object. Make sure to import this from the API folder, because there's also a comment type that is used without any imports, but this is the wrong one. So make sure to import this from the API folder. So you should have this line up here, import comment. Otherwise you will get weird errors. So this is the return type, because this is what we return here. We return this object with the comment inside it. So now that we declared this here, React Query knows that in the onSuccess callback, we get this comment back. So now this has the correct type. This is the comment that we get back from our post data call. And now we want to put this into our cache. We also have to make onSuccess an async function because we need to do async operations in here. So let's start at the top. We actually don't need invalidateQueries anymore. We can call this at the end after changing our cache if we also want to refresh this, but this is not really necessary. So let's remove this. And this requires a few steps, but all of this is hidden in this custom hook so we don't clutter our components with all of this logic. First of all, we call await queryClient cancel queries, to which we have to pass the query key, which is our comments key here. But instead of repeating this over and over again, we can put this into a variable, which we put here outside of our two functions so that we can use it throughout the whole file. We create a const queryKey. We set the type to queryKey, which is an import from TanStack. And here we assign this array with comments inside it. And then we can use this everywhere we hard-coded comments before, like down here. Or here where we pass the queryKey, right? Okay, so we have to cancel this ongoing query. Why? Because otherwise it could happen that we update our cache and then we still get some new data because this request was already running. So this would be another race condition. This is why when you mutate the cache yourself, you always want to start by canceling the running query. Then we call queryClient setQueryData, the singular one, not queries, but query. And here we can modify the cache. Now when we use useInfiniteQuery here, this is a little bit complicated because the data in here is quite nested. We have pages, we have page params. Each page is an array of items. In each page we have our comments, but also the next cursor and the total comments. This means we have to write a little bit of logic here to actually get into this array and put our new comment in here. So this is a bit more involved, but it's important to learn how to do this. So first of all, we set the type of that query data to the type we want to modify. Since we use useInfiniteQuery, we have this helper type, InfiniteData, which is another TanStack import. Here we have to add another type argument. What's the data that we get back? That's our comment response. So this is the same data type as we get up here, right? This is the data type that's inside our pages. After comments response, we make a vertical bar, and now we have to pass the type of our cursor, which is number or undefined. So when we add this here, and then two closing angle brackets, we get type safety for that query data. Okay, cool. Then parentheses, so now we call this function. Again, we have to pass the query key as the first argument, because we want to modify our comments query, this one here. And the second argument is a function where we receive the old data. This is the data that is already in our cache. And now we can update it and return it. So this is how we basically go right into this cache. And this is the old data, the stuff you can see in here. And now we want to take our new comment and put it into the first page because we want to show it at the top, right? So we want to go into this first page and put it here into this comments array. And updating the cache works similar to how you update state in React. You shouldn't mutate it directly, instead you should return a new copy. So what we do is we want to get the first page in here, inside this function, which is old data dot pages, but old data can be undefined, so we have to put a safeCal operator here, and then we want to access the first element. And if this is now defined, we know that we have at least one page in our cache. So below we check if first page is defined. Then we want to return an object. And this object is the updated version of our data, which we want to put into this cache. So what we do is first we spread old data in here. And old data basically contains the pages and the page params. So instead of like this, we could also write page params colon old data dot page params. It has the same effect as spreading the old data here and then passing the pages separately below. But I like this syntax more. We want to change the pages, right? Because into these pages we want to put our new comment. So pages is an array. And what do we want to do here? We want to take the first page and put our new comment here at the first position. And we also want to update the number of total comments so that this also changes properly. So inside pages, we put an object. This is our first page after the update. Here again, we spread the first page to keep the values in there. We update total comments. We want to set this to first page dot total comments plus 1. We get an error here because I declared this type here wrong. As you can see, I wrote comments response and then 2 vertical bars. The first vertical bar here should be a comma because the second one is the type of the cursor. So now this should have the correct type. And then after total comments, we have to pass the comments array itself. So those are the comments in the first page where we want to put our new comment inside it, right? And the new comment is the one that we return from the backend. I know this is very confusing, but we are almost done. And once you have done this 2 or 3 times, you will understand how this works, and then it's easy. And of course, you can always take a look at this repository again as a reminder. So into this comments array, which is this array here, we put the first comment at the first position, and then we spread the existing comments, because we want to keep them in here, right? And then lastly, inside this pages array, after the first page, we have to spread the already existing pages, right? Except the first one. So we spread old data dot pages dot slice, where we pass 1 to remove the first page, because the first page is this one here with our update. And that's it. Before I push this project to GitHub, I will also add some explainer comments here in case you need a reminder what these different functions do. So you can always look at this repository. And again, after calling setQueryData below, you can also call invalidateQueries to refetch the latest data, but it's not really necessary. And it's also a bit wasteful in my opinion in a paginated list. This was a lot of work, but the benefit is that now we don't have to wait for these pages to revalidate. Instead, we take the comment response we get from our post endpoint and we put it in here directly. So again, let's load all the pages so that we have the maximum loading time. And then let's see if this is faster. I make a new comment. This should be faster. We post and we see the update immediately. This is much better, isn't it? Because now we don't have to wait for the revalidation. And when an error happens, then it will just not post this comment at all. Let's try this out as well. Let's set the error chance to 100% just for a moment. And this shouldn't work at all. Instead we get an error message and we can try again. Let's reset this. But we can even take this one step further. Instead of waiting until the request has finished, we can also do an optimistic update. This means we put the new comment into this list immediately without even waiting for our post request to finish. And then if an error happens, we just remove the comment again. You can do this with React Query as well. Let's see how. To implement optimistic updates, let's create a new file in the same folder as our use comments hooks folder here inside InfiniteQuery. New file, and let's call it use comments hooks optimistic.ts. In here we will do the same as in our existing mutation, just that we update our comments list optimistically instead of waiting for the response. So here we export a function called use create comment mutation optimistic. I only add optimistic to the end because I want to make the difference clear. In the real app, I would just call this use create comment mutation or even just use create comment. But for this example, I give it this very explicit name. Okay, this will look very similar to the one we already have. First, let's copy the query key over here. Let's paste it above. Import the query key type. We will also need the query client, which we also have to import. Use query client. And then we want to return useMutation, parentheses curly braces, with the same mutation function as over here. This is all the same. Import post data. And we basically want to do the same as we did in onSuccess. We want to update the cache directly, but this time we don't want to wait until the request was successful. Instead, we want to do this immediately. So instead of onSuccess, we add onMutate, which will be executed as soon as we call mutate, even before we get the response back. So now we pass an async function here, and again this function receives data. This is whatever we pass to our mutation function. So it's this part here, the comment with the text inside it. It's not a comment from the server because we don't have a response yet, but it's the input. So we call this new comment data, and in here is this text. And we have to make this an arrow function like this. So now we can find the text in here. Okay, great. So the process is very similar to what we did over here. First of all, we have to cancel the running query to avoid race conditions. Then before we set the query data, we want to get the already existing query data, because if we get an error, we want to reset our comments list to this previous data. And again, in the documentation is an entry for these optimistic updates, but you can just follow along. So we create a const previous data. We take the query client, call get query data, the singular one, this one. And again, we have to define the type of this. This is the same InfiniteData type as over here, because this is what's inside our cache, right? So we set the type like this, we import these types. But we also have to call this function, and to it we have to pass the query key. So now in here will be the already existing cache entry without our new comment yet. Then we want to put this comment into the cache, similar to what we did over here. But again, this time we don't have the full comment with the created at timestamp. There's also no ID in here. We basically only have the text and nothing else, because the rest is set on the backend. So we have to create a dummy comment instead. So what we do is we create a const optimistic comment. We set the type to comment. Again, import this from the backend. It's important that you import the correct type. Otherwise you will get weird errors. I had this problem in my preparations. And now we get autocomplete in here. We have to set an ID. We can just set this to the current date, because we only get a real ID after posting this to our backend. The text is simple. That's contained in the new comment data, right? That's our input. We also have to set the user. Again, this would usually come from your authentication library. Here I want to use the same user data as we have on our backend. Somewhere down here, current user NCU. So we hardcode this here, but again, in a real application, you would use the user data from your authentication service. And lastly, we need the created@at timestamp, which we can set to the same value we used over here. New date to isostring. So now we create a fake comment, because again, we haven't gotten a response from our server yet. So we create a fake comment instead. And now we want to put this fake comment into our cache. And the good thing is now we can just copy the setQueryData function that we already used over here, and we don't have to write this again. So let's copy this whole block, post it below our optimistic comment, but instead of the comment that we get from the server, we put our optimistic comment in here. Okay, cool. Then one more thing, at the bottom of our onMutate function here, we want to return this previous data. So down here, make sure to put this at the correct place. We return an object that contains the previous data. And we are almost done. This return value is necessary because if we get an error, we have to reset the state of our comments list back to what we had before. And we do this in the onError callback. We can use this function definition where we receive these three arguments, and in the context is whatever we return from the onMutate function. So in here, we can take the query client, call that query data again. Again, we pass the query key, and then we can pass context.previousData. This will reset the comments array to the data before we attempted our update. Yeah, that's it. This is our optimistic mutation. Again, it's a bit complicated, but this is how you do it. This is how you do optimistic updates with React Query by really going inside the cache and changing it. And the cool thing is, these optimistic values are synchronized throughout your whole app. So again, if we show these comments in multiple different places, they will all show the same data because they all get their data from the same cache. This is especially useful if you have something like a like button or a follow button, because if you show them in multiple different places, they will always be in sync, which is really cool. Okay, then let's go into our comment form. And instead of useCreateCommentMutation, I'm gonna comment this out. I assign this to useCreateCommentMutation optimistic. Then just for this one operation, let's increase the loading time here. Let's increase this to 1 second more, maybe, to have a really long loading time. But since we have an optimistic update, we should see the new comment inside here immediately, before this has even finished. This comment should be posted immediately. So I click on post and it's inside there immediately. Then it would also make sense to maybe not disable this button, right? Because otherwise it looks a bit weird. No, actually, let's keep it disabled because we want to keep our input until this has finished. But no matter how many pages we have loaded, we see the new post instantly. So what happens if we get an error? Let's try this out as well. Let's set the error chance to 1. Again, I post. We see it immediately. Then we get our error and the post is removed. And we can try this again. Again, optimistic update, rollback. This is an important concept of optimistic updates. But then eventually we will succeed in posting this comment, and then we see it in our list and this input field is empty again. And of course, we also see these optimistic changes here in the DevTools. So in here right now we have one page. Because I refreshed the page, let's load 2 more. Now we have 3 pages. In here are 3 items right now. And when we add a new one, now 5 items actually, because it's this comments array, right? Here are our 5 comments. And when we post a new one, it should be put in there as the 6th item. There we go. And it's put at the 1st position. Again, check out my social media app tutorial for a real world use case. There we use optimistic updates for like and follow buttons. I hope you enjoyed this tutorial on React Query. If you did, please leave a like on this video and subscribe to the channel. If you want to see a more advanced tutorial on React Query, let me know in the comments. Also let me know what other topics you want to see tutorials about. I read every single one of my comments. Also, I have a free React Best Practices email course, which you can find at codingandflow.com/reactbestpractices. When you sign up, I will also put you into my free email newsletter. Of course, you can unsubscribe at any time, but you probably want to stay in there because I send my best web development tips every 1 or 2 weeks to this newsletter, and it's a really nice way to improve your web development skills. So again, go to codingandflow.com/reactbestpractices to get the free course and join the newsletter. And then I wish you a nice rest of the day. Happy coding. Take care.